Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. In this session, we will discuss the remaining of tutorial 1, which is from question number 10 until question number 15. So, we start with question number 10. In figure 1.9, three potential lines are drawn around a charge. Line A is at potential 10, and then positive 8, and then positive 5. If the charge is positive or negative, justify your answer. Okay, if you try to redraw the diagram, then you can see that this one is actually the charge, position of the charge, and then you have the position of equation line C, B, and A. And you can see that as the R is decreasing, the potential is increasing. Okay, or you can look the other way around. When the R is increasing, the V is decreasing. So that one is actually show the behavior of a positively charged particle. Over here you can see that this is the graph of potential against R. As R is decreasing, the potential is increasing. So this one would be a positive charge. Question B. A charge of 3 microcoulomb is placed on a line C. Calculate the work required to move the charge along line C for one circumference, returning to its starting point. Okay, so number one, it says here that the charge is moved along the line C, so it doesn't have any change in V. Okay, so if along the same equipotential line V is constant, that means delta V is equals to 0. So if delta V is equals to 0, then your work is actually equals to 0 as well. Okay, the second part, they want to calculate the work required to move charge along the radius of the circles from C to A. Okay, so obviously, if you want to calculate work, you can use Q naught delta V. Okay, here delta V means final minus initial, potential final minus potential initial. In this case, final is at A, initial is at C. So you have to read the question carefully. Line C to line A means that C to A. So VA minus VC. Okay, so you just have to substitute the value. So the Q naught is given in the question here, 3 microcoulomb. Just substitute there. And then 10 minus 5. So it must be final minus initial. And you should get 1.5, then 10 negative 5. Okay, this one just now is actually positively charged. Okay. Question 11. 2-point charge Q1 and Q2 are 0.1 meter apart. Point A is midway between them. Point B is 0.08 from Q1. Okay, so as shown in the diagram. Determine A potential at point A, B potential at point B. And then question number C, they want you to find the potential energy of the system. So I'm not going to do the A, I'm going to skip A because I think that one is very similar to B. But we discuss the B. So if you want to solve for B, first thing first, you have to take out all the information. Identify the charges. So this one is 24 nanocoulomb. This one is negative 6.5 nanocoulomb. The important information here is the distance from the charge to the point, which would be R1B, and here is R2B. This one already in meters, so should be okay. If it is in cm, then you have to change to SI unit. So if you want to calculate potential at B, you have to identify how many charges are there. So here in this case, you have two charge. So that means you have two potential. One would be, so potential at B, you have V due to 1 at B, and V due to 2 at B. I just have to substitute the value lah. The formula is KQ over R, KQ over R. One correspond to Q1, another one correspond to Q2. So here I factorize the K, take out the K, put it in front. And then I just substitute the charges. Remember that the potential here is a scalar quantity. So if you have a negative sign over here, this one, just remember, negative for scalar quantity. And then the answer should be negative 705 volt. If you get negative, you just leave the answer like that. And then the next question, they want to find the potential energy of the system with the charge negative 4.5 nanocoulomb is placed at point B. So now the question state that they put negative 4.5 over here, so at B lah. So now you have three charges. This is the system lah. The question is to find potential energy. So don't get confused potential with potential energy. If the keyword energy, then you need to use U. So if you want to use U, the formula would be KQQ over R. So for each pair, example here, pair of Q1 and B, you will have one potential energy. For B and 2, you have another potential energy. So for each two charges, you will have one potential. Okay. Between 1 and 2, another one. So for 3 charges, you will have 3 potential. So to find the potential energy of the system, you just have to add all the values. If you have a negative charge, you just substitute negative sign inside the formula. Okay, so this one, even though it seems like a little bit long, but I think as long as you press your calculator correctly, you shouldn't have any problem. So maybe if you're not confident to press everything at once, maybe you can calculate this part first, U2B and U12. Okay. Common mistake would be prefix when pressing the calculator. And then sometimes factorize the K but then forgot to multiply with K. Another one is student get confused with the charges here, the value. Okay, so here the answer will be 1.77 times 10 negative 6 joule. So answer for energy, the unit is joule. For potential, the unit is V. Okay, this one is the same. The question number 12 shows a uniform electric field with a strength of 2.7 times 10 to the power of 5 Newton per coulomb. So this one would be your E. And the distance between the plate is 0.078 meter. That one is your D. A proton is placed inside the field at A. So they put a proton over here. Doesn't state specifically where, but just inside the field A. So this one, if you have two metal plate A and B, you will expect this one is a uniform electric field. Question number A, they want to find the work done by the field on the proton. Okay, so if you want to find the work done, obviously you have to use Q delta V. Q naught delta V. So Q naught for proton is basically just a charge, 1.6 times 10 negative 19. but you have to find the delta V first. How do you find the delta V? It comes from the equation of E equals to delta V over D. Rearrange this one. You will get delta V equals to ED. So E is given, electric field 2.7 times 10 to the power 5. D is equals to the spacing between the two plates, 0.078. If this one not in meter, you have to change to meter. And you should get delta V equals to 2106 volt. Substitute inside the work question just now, and then you should get the answer over here. Question B, they want to find the gain in the kinetic energy. So if you guys still remember from last semester chapter 5 energy, where you have work energy theorem, where work is equals to delta K. So work done on the object ataupun or charge will result in gain in kinetic energy. So here is basically work equals to delta K. So you just, wait, what is delta K? Okay, see the potential difference between A and B. Which plate has the higher potential? Delta V is basically the one that you already calculate above here, where delta V equals to ED, which is 2106. You just have to rewrite. And then the question asks the potential, which plate has the higher potential? So you can determine based on direction of electric field. So electric field will always flow from higher potential to lower potential. Like in this case, you can see that the direction is downwards. So it means that above here at A has higher potential compared to B. Remember, I repeat, electric field must flow from higher potential towards lower potential. So here A, V at A is higher than V at B. This one, So plate A has higher potential. Maybe you want to rewrite that one. Oops. So I still have to wait. Okay, plate A has higher potential. Okay, B. Question 13. A pair of parallel metal plates are separated by 1 cm and a potential difference is applied across them. An electron is released from rest at negatively charged plate. It reached the positively charged plate at a speed of 2 times 10 to the power 6 meter per second. Okay, so the question here didn't give you any diagram. So basically you have to imagine a pair of parallel plates. So you have to draw the metal plates first. Okay. Okay. A pair of parallel plates. You draw the metal plates that I draw just now. Okay. Separated by 1 cm. So that one would be the distance between the two plates, the D, and a potential difference is applied across them. An electron is released from rest. So the keyword here is from rest. That means your U is equals to 0 at the negatively charged plate. So the position would be over here. Okay, it reached the positively charged plate at speed of 2 times 10 to the power 6. That one is your V. So you can take out the information, draw it over here. Determine the gain in kinetic energy. So the gain, you can calculate the gain in kinetic energy by using formula of delta K. Since delta K is K final minus K initial. Remember that U is equals to 0. So K initial is equals to 0 as well. So delta K, you only have KF. Use the velocity for final. Since this one is electron, so you need to use mass of electron. Okay, mass of electron, if this kind of question came out in exam, you can use the mass of electron inside the list of constant in front of the question. So delta K is equals to half 9.11. Here I use 9.11 times 10 to the power of negative 31. Don't forget the square here, and then you should get 1.82 times 10 to the power negative 18 joule. That one is for question A. Question B, the difference in potential difference across the plates. So basically the question wanted to find delta V, potential difference. You can relate with work, okay, where work is equals to Q naught delta V. And then if I rearrange delta V, it will be delta V equals to work over Q naught, and then from work energy theorem, work is equals to gain in kinetic energy ataupun delta K. So it will be delta K over Q naught. Q naught here is the charge of electron. Okay, so because we are talking about scalar quantity over here, if you have a negatively charged electron, just substitute the negative value inside the equation. So you got negative 11.38 volt. Okay, the question actually state, the question wanted to find the difference in potential. So it doesn't state from where to where. So sometimes if you answer positive, like delta V equals to positive 11.38, is correct as well. Okay, C. The magnitude of electric field strength between the plates. So you already have delta V now, and then you have D, the distance. So you can use E equals to delta V over D. Okay, so this one for question C. Now for question D, the acceleration of electron. So for question D, yang C just now, you just substitute inside the formula. Yang D, you can redraw this electron over here to identify the forces on the charge. So here we ignore the weight in this case because the weight is very small. So if you want to include the weight, it will be Fe minus W. But here I ignore lah. So Fe is equals to MEA, mass of electron A. So obviously you have acceleration in this case. So Fe, if you're looking at the definition of electric field E, which is equals to F over Q naught. So F is equals to Q naught E, this one. And then I can rearrange A to be E over ME. This one is actually Q naught. Because we are talking about charge. So that one is 1.6 times 10 negative 19. Charge of electron, sorry. E is 1138. And then ME is 9.1 times 10 negative 31. The E value you got from question C. Mass of electron, again, that one is just a constant, 9.11. Okay. And then A is equal to 2 times 10 to the power of 14. And then for question E, the time taken by the electron to travel from the negatively charged plate to positively charged plate. So here you already have the distance, you have U, you have V, and then you even have A. So you can calculate the T time using kinematics of linear motion. Okay, in this case, I use V equals to U plus AT. You can use other formula as well. So T is equals to V minus U over A. V is 2 times 10 to the power 6. This one from the question itself. Minus 0 because U equals to 0 divided by A, the value that we got just now. And then you will get time equals to 1 times 10 to the power of negative 8 seconds. So notice that this one happened very quickly. So it is even less than 1 second. the time required for electron to travel from negative plates, negative plates to the positive plates. Okay, question 14. Two parallel plates, the length is given 0.06 meter, are separated by the distance 0.025, this one is the D, and have a potential difference of 850. So diagram is given, so easier. Point P is located midway between the two plates as shown above. So exactly in the middle there. What is the magnitude of the electric field at point P? Okay, you have two metal plates. You will expect that if I want to draw the electric field line, it will be straight like that. Okay. So if you have two metal plates, basically you have a uniform electric field. Okay, I'm gonna draw it properly here. So if you want to draw it properly, the spacing between the lines need to be the same to indicate the uniform electric field. And then electric field will flow from higher potential to lower potential. Okay, so this is your E. Then if you have uniform electric field, you can calculate using E equals to delta V over D. Delta V is 850 minus 0, and then divided by D, 0.025. Okay, for the last question. The electric potential of a point which is at a distance x from a point charge is 600 volt. The electric field strength at that point has a magnitude of 3 times 10 to 3 kilovolt. Determine the distance of the point from the point charge. Okay, so this is just a diagram to represent what the question is saying. Yet the potential point which is at a distance x from a point charge is okay. So here at certain point, distance x, the V is positive 600 volt. This is the charge. Electric field strength at the same point is 3 times 10 to the power of 3. Determine the distance of the point from the point charge. So basically the question wants to find x. Okay, from the formula of V equals to KQ over R and E equals to KQ over R square, I actually can cancel out all the terms where KQ is basically a constant to end up with R. So here I have a square term. It's only one, so I can divide one but with another. So in this case, I divide 1 with 2. So it would be V over E KQ over R divided by distance KQ over R square. So if I change to multiplication, I have to flip the term over here. So I can cancel out KQ, R cancel out, you left with 1R. So R here is actually the X lah. But just leave in R equals to 600 divided by 3 times 10 to the power of 3. That one's come from V and E. V over E. So R is 0.2. So because everything is in SI unit, so final answer would be in SI unit as well. The second question, they want to find the charge of the point charge. So you can use either V or E. So in this case, I use V equals to KQ over R. Now you just have to substitute V, R, and K, all the values inside. You should get Q. Okay, if you want to use E, then you can use E equals to KQ over R square. Again, just substitute the value and find the Q. The answer should be the same. Okay, so that's all for this session. Thank you.